Welcome to viewers. This is Jahangir from Tech Jahangir YouTube channel. Today I have created a new video how can data analyze and visualization in cluster dendrogram by using RStudio computer program. If you are new to my channel, please subscribe me, and if you have already subscribed, so thank you. Give a friend a chance to watch the video by liking and sharing. Okay viewers, let's start how can data analyze and visualization in cluster dendrogram by using RStudio computer program. Okay viewers, let's start how can data analyze and visualization in cluster dendrogram by using RStudio computer program. First we have to see what was our data sheet. So it is our data sheet, my data sheet name genotypes 30. It is 30 genotypes, the CB1, 2, 3, 4, 5, 6, 7, 8, 9, and that is 30 genotypes, and that is our dependent independent variable. Just a flowering, number of bulbs per plant, ball split, NFB, vegetative branch, primary fruiting branch, single ball weight, maturity date, and yield. It is our dependent independent variable. The yield is a dependent variable and all are the independent variable. So 30 genotypes. First now we can analyze data and cluster dendrogram. First we have to open RStudio software. It is our RStudio software. Now we can call library and data sheet. Now we can first we can run. So our library data sheet is run, and now we can write read .csv. First we have to now this read data csv file, and it is our first C type user, and my data file name is genotype 30. We write genotype 30 and the storage in data. So run, now we can run. Okay, our data is loaded. Now we can see what is our data file. Open data. So it is our first column genotypes, and second and other column is dependent and independent variable, and first column genotypes 1 to that is 30 genotypes. So now we can first we have to save this file. Now file name cluster, so we can first save this file. So our data is loaded. Now we can see dim our data, that is dim file name is data. So now we can run. So that is 30 observation and 10 variable. Now we can see structure. Our file name is data, so we can run. So it is our structured data is data frame, 30 observation and 10 variables. That is genotype is factor variable, and other dependent independent variable are integer or numerical variable. So now we can see type of data. Type of our file name is data, so we can run. So it is our list file. Now we can see class file name is data, so it is our data frame. And now we can see head data file, head of data. So the head data, first genotypes, second just flowering, number of ball split, NAB, vegetative branch, primary fruiting branch, secondary fruiting branch, maturity dates and age. So it is our data main head, that is six row. We have only observation 1, 2, 3, 4, 5 and 6. So now we can see scatter plot. Now write plot, and we are our independent variable, it is yield. So we write yield versus will depend on number of bowl, primary fruiting branch, etc. So we can write NB, that is our NB, number of bowl. So and it is our data. Okay, first we can run this. So it is our scatter plot, and now we can see with our file name is data and text from text. Now our independent variable is yield versus NB. So we can again run. So we can see it is our genotype name and genotype, that is different genotypes, all are the similar, but 30 genotype is the dissimilar. Now we can see levels is equal to our first, all are the genotype. So write genotype, and we can again run. So we can see it is our that is genotype name. So it is not clear. So we can position, it is position is equal to 1 and size 0.5. So we can run this. So it is our small size, so we can easily see CB1, CB2, etc., and 13 the last genotype BC 479. So we can see this. Now we can write normalization, write data. We can see, that is we can all row and column on and this is stored in Z. So we can run. Now we can see Z, that is our DF data flooding. Only first column is omit and second, third and other column is source. Our data is, it is first column genotype, second column DF, but we can see only DF plus first column is omit. So now we can apply there is Z into and 2, and we can mean, and it is storage in mean. We can see, I want to see the mean value, so it is mean. Okay, now we can store. Okay, now we can see mean, it is our mean value, that is DF dependent variable, it is our main value. Now we can apply standard deviation, it is Z2 and SD, and we can storage in S. We can store in S. So now we can run this. So we can write S, and so it is our standard deviation, it is mean value, and it is our standard deviation. Now we can write scale and Z M S, and we can storage in Z. Now we can run this. and we can see Z again. So it is different from other, and so it is different variables and their attribute scales. Now we can calculating Euclidean distance. Right, first we can write distance, and our file name is already, we can store it in Z, so we can write Z, and we can storage in distance. So we can run this, and we can see write distance, and we can enter. So it is our distance from, that is our genotype 1, 2, 3, 4, 5 and 30 genotypes, that is 30 genotype. So distance between one and other genotype. So it is, we can see genotype 2 and genotype 1 distance 2.37 to 357.047. It is large digit, longer digit, it is more than more digit. So we can print. Now we can print and distance, and we can write digit is equal to only 3 digit. Now we can run. So it is our distance, genotype 1 to genotype 2, genotype 3 to genotype 1, and different distance. Now we can cluster dendrogram with complete linkage. So cluster dendrogram with complete linkage. Now we can write AC, that is H cluster, and it is distance, and we can store in AC helical cluster into C. That's mean complete linkage. Helical class into complete linkage. Now we can run this. It is our helical cluster complete distance. Now we can plot AC helical clusters, and now we can run. So it is our dendrogram, that is complete linkage. We can see that is one genotype is number 30, that is one genotype is another distance, and all are the similar. That is, first we have seen 6 and 8 genotype is cluster 1 is length is, it is this lower distance, this is similar genotype, but 30 genotype 30 is different from other genotypes. So now we can see label is equal to our data name is data, and $sign we can genotypes. Now we can run. So we can show it is show our genotype name. First we have seen genotype number, but we have seen genotype name, genotype CB1, 2, another. So and it is our genotype BC479. Okay, now we can see plot helical cluster into complete linkage and hang is equal to -1. So now we can see it is our, that is genotype, that is all other genotype number is serially serially located here. And now we can write level, we can copy there, and again we can run. We can show genotype name. So it is our cluster dendrogram and complete linkage. Now we can cluster dendrogram in average linkage. So we can average linkage. So first we can is classed and we can write distance and method average linkage, and we can store it in ac.a. That's mean average linkage. Now we can run and plot ac.a, that is average linkage, and -1. So we can run. So it is our average linkage, different from complete linkage. So it is height, and it is our cluster distance average, and it is dendrogram. Now we can see again. So it is a complete linkage genotype, that is 30, 20 and 28, and it is our last. We can see it is our average linkage genotype, that is 29, 22. It is difference from. We can see the highest value of genotype 30 with genotype difference from genotype 5, that is highest value, and the lowest value, it is cluster distance and it is height for cluster, and 4, 6, 8, 6 and 8 is first. So we can see 6 and 8, 1.8, it is lowest value. It is similar, it is similar value, and lowest distance from genotype 8 and genotype 6 genotype. So we can see in dendrogram genotype 6 and 8 is similar. Now we can analyze cluster membership member dot c, that is mean cluster membership, and country linkage cluster means complete linkage, and we can write 5 cluster. So we can run. It is our membership, write member dot c. So it is our membership, a complete linkage. First genotype cluster 1, second genotype cluster 1, third genotype cluster 1, fourth genotype cluster 2, 5 genotype cluster 1, 6 genotype cluster 2, that is forward, and last genotype is cluster 5. So now we can member in average linkage. So we can copy and write linkage cluster into A, average linkage. We can write A, and we can run and write member A. That mean a complete linkage. First genotype cluster 1, second genotype cluster 1, third genotype cluster 1, and fourth genotype cluster 2. But in average linkage, fourth genotype is cluster 1, and difference the last genotype is cluster 5 and 5, but 28 genotype cluster complete link is cluster 4, but average linkage is cluster 3 located. So we can write table member.c and member A, right? Member C and member A, bracket close. We can run. So it is our complete membership in average linkage and membership in complete linkage. So first genotype, first cluster 1, 16 plus 7, that is mean 23 genotype in cluster 1, and cluster 2 genotype, cluster 3 genotype, cluster 4 1 genotype, and cluster 5 1 genotype. Consider in membership cluster membership in average linkage. But when the cluster in complete linkage, then first cluster 1 only 16 genotype, and cluster 2 7 genotype, cluster 3 contain 2 genotype, cluster 4 contain 3 FL plus 1 4 genotype, but cluster 5 only 1 genotype. It is different from complete cluster membership, that is complete linkage and average linkage. Now we can see cluster mean, right? Aggregate and our it is Z and list member C, let member C and mean. So we can run. It is our it is group cluster 1 2 3 4 and 5, and complete linkage mean value for days to flowering, the number of bole speed, etc., date maturity and yield. We can see it is cluster 5. It is a difference from different cluster, and it is, we can only show it is a yield. When consider yield, it is a highly difference. It is difference from minus 1.4 and plus 1.27. it is cluster 4 and cluster 5 is more different, that is difference from consider yield. But when we consider primary fruiting branch, that is 0 0 minus 0, that is more similar, no difference from the cluster. Now we can aggregate. Now we can write aggregate. Our file name is data, and we can write all row but column one column, and we can write list, that is member complete C, and write and mean. Now we can run. So it is our original group membership, that is days to flowering, yield, that is 3.5 ton yield per hectare, 3.87 yield per hectare. It is original link data. Now we can see how to plot. Now we can library cluster. Now we can run. So our library is running. Now we can write plot Silhouette and cut tree hereditary cluster, that is C and 5 cluster, and we can write distance. So we can run again we can run this. It is our CLU to wide distance plot. It is genotype 10 and genotype 28 is SI. SI is negative, but all are the positive in case. So we can write script plot. Now we can write a script plot. We can write WSS with sum sub square is storage is sum sub square WSS n row or is z minus 1 sum apply z to variable. For I in our genotypes only 30 genotypes, so we can 2 to 29 OSS, that is we can run again, and our x level number of cluster, y level within group, that is within group WSS, and plot 1 to 29. Now we can run all 3 lines. Okay, it is, we can see it is our within group sum sub square, that is we can number of cluster, that is 5 10 15. It is our curve, that is right side and low down. It is our first. Now we can cluster 1, cluster 2. It is cluster 1 and cluster 2 is long distance. Cluster 2, cluster 3 is long distance. Cluster 3 4 long distance. 4 to 5 long distance, but other, that is 6 7 8, it is our smaller distance. It is non-significant, but it is cluster 1 2 3 4 5, it is significantly difference. So we can only choose how can cluster we can calculate it. So it is only 1 2 3 4 5 5. It is that is curve, low down curve, so we can choose only 5 cluster. Now we can see k means cluster, that is k means cluster. Now k means and our z and 5 cluster. So we can run. It is our k mean clustering with a 5 cluster and size 8, that is 8 first cluster 8 genotype, second cluster 3 genotype, and 3 cluster 9 genotype, 4 cluster 1 genotype, and 5 cluster 9 genotype. It is our cluster that is mean cluster 1 to 5, and it is this to flowering, number of balls, ball speed, etc 8. It is that is difference from 0. It is not difference, but it is difference from cluster 1, cluster 2 and cluster 3. If 4 cluster is highest. So now we can plot, that is yield versus. Now we can see yield versus, that is our first. We can see yield versus number of ball, but we can see yield versus days to maturity. So we can write MD, because our variable is write MD, days to maturity, and we can write data and color is equal to KC $signs cluster. Now we can run. So we can see it is our cluster distribution, maturity versus yield. Cluster 1 came in cluster. Now we can see KC $sign, that is cluster. We can run 2 4 first genotype cluster 2, second cluster 5, and write KC $sign centers, run. It is mean value, that is cluster 1 2 3 4 and 5. Now we can write cluster C, it is total sums of square. We can see total 261. Now we can write cluster within sums of square. It is our within sums of square, first cluster, second cluster, third cluster, fourth cluster, fifth cluster. First cluster is and very, so it is our now KC $sign size. It is our cluster size. First cluster 4, second cluster 9, third cluster only one observation. So third cluster is 0 0. It is lowest value. So it is this genotypes is different from other genotypes. Now we can write KC $sign, that is iter. Now we can cluster 3 is best from other genotypes, and we can see in this dendrogram. You can see in the dendrogram first 1 2 3 4 and 4, and only one genotype is different location, and we can see now 4 genotype is cluster 1, that is 1 2 3 and 4 is cluster 1, and cluster 2 10 genotypes. Cluster 10, that is mean 1 2 3 4 5 6 7 8 9 10. Red circle is cluster genotype 10 is cluster 2, and cluster 1 3 only one genotype, that's mean a difference location one genotype. And cluster 4 belongs to 6 genotype, that's mean 1 2 3 4 5 and 6. It is blue color circle contains 6 genotype, and 5 cluster 5 genotype, cluster 5 belongs to 9 genotype, that mean 1 2 3 4 5 6 7 8 and 9. It's mean green circle. So it is our cluster analysis. Thank you. I hope it will be helpful for you. Okay, thank you.